Hello everyone, welcome to Clash Encoder. So in this video we will see the question number of islands. So this is one of the most liked question on the lead code. You can see 7,000 likes and it is a medium level question, and this question has been asked for various interviews for Amazon, Citrix, T-Shaw and LinkedIn, Microsoft, Paytm, Samsung. So this is really important question from the perspective of coding interviews. So let's see the problem statement and then we will see how we can solve this question. So it is actually similar on the both Geeks for Geeks and lead code platform. Just it is that the constraints are more on the Geeks for Geeks platform. So let's see what is the problem statement. So given m into n 2D matrix, or you can say grid map of ones that is land and zeros that is water, return the number of islands. So that means we are only given a 2D matrix with which is consisting of ones and zeros. That means it is a 2D binary matrix. So we have to return the number of islands. So let's see what is the islands. So an island is surrounded by water and is formed by connecting adjacent lands horizontally and vertically. So actually if you see horizontally and vertically, it means that top, bottom and left and right. So that means horizontally will be left and right, and top and bottom will be vertically. So we have to consider four directions, and you may assume that all four edges of the grid are surrounded by water. So that means we have to count the number of islands in this matrix, and one is considered as land and zero is considered as water. So I will explain you. So here let's see on the example. So this is the first example that we given, and here the answer is 1. So let's see how it is 1. So just one thing, so check here, you can see you may assume that all four edges of the grid are surrounded by water. So an island is a thing that is surrounded by water. So here one is land, so that means if it is an island, so it should be surrounded by zeros on all its four sides. So that we are considering. But here you can see, here we are given the constraint that you may assume that all the four edges of the grid are surrounded by water. So that means if this is an island or this is a land, it is surrounded by water. So this is water all over the four directions of this matrix. So let's see how the answer is 1 here. If you see, this 1 is here, and we have to connect all the lands. You can see we have to connecting the adjacent lands. So if we connect them horizontally, it will be, you can see these are connected and this is vertically connected. So this is forming a one line, and you can see all these are connected in using their four directions, and they are surrounded by zeros. That means water on the bottom, you can see bottom side and on the right side, and on the top side you can see they are out of bounds. So that means there is water all over them. So that means this is an island. So this is one island that is formed. So our output is 1. So if it was like here it is 1, okay, here it is 1. So this is one island and this is the second island. You can see this one is surrounded by this zero and this zero. It is surrounded on the this two directions, and on this other two directions there is water. As you know, out of the bounds there is water. So that means this is also surrounded. So it will be output will be 2 if we have one here. If we have one here, okay, so it will be actually connected. This will be considered as one island, because on this one's left hand side, that means vertically, there is more land. So we will connect it and it will form a total island. So the output will be still 2. So let's see what is the constraint that we are given on the Geeks for Geeks, which is different from the lead code. So on the Geeks for Geeks, actually you can see everything is similar, but here if you see either of the 8 directions, so that means here we were considering these directions, okay, top, bottom, left and right. But in Geeks for Geeks we will consider these directions also, top, bottom, left, right and diagonally. So that means there will be total 8 directions. You can see 1 2 3 and 4 5 6 7 and 8. Here it was 4 directions. So this is only different in the both platforms. And also you can see the time complexity, expected time complexity is m into n, that is number of rows into number of columns, and the space is also similar, m into n. So let's see how we can approach this question now. So let's see. So this is a second example. So here the number of islands will be, actually if you see carefully, the number of islands are, you can see 1 1 1, and here I am considering as in the lead code platform, and I will show the code for both Geeks and lead code, but here I am only considering the 4 directions. So that is why our island, this will be one island. On the Geeks for Geeks, actually this will be also connected. This will be forming one actually you can see one island. This all will be forming one island on the Geeks for Geeks, but on the lead code there are only 4 directions. So you can see this one is surrounded by 0 on the top, on the bottom and the right side. So this is actually forming one island, and you can see this is forming the other island. This you can see it is connected from the bottom, and this is forming the other island. So output is 3. So let's see how we can now solve this question, as you would have got to know how the example works. So let's see. So if you consider, like if we traverse this matrix, so we have to return number of islands. Why not traverse the matrix? If we traverse this matrix, so it will take actually for 2 follows to traverse the matrix. And if we traverse the matrix, if we are on this element, what we can do is we can check all its adjacent elements on the 4 directions, and if it is 1, like if its right side is 1, so we will traverse this, okay, we will mark all these elements. You can see all these elements. So when we get like all these elements as 1, so you can see we have got one island. And if we get 0, okay, if we get 0, So we know that it is not land, so we will stop here. So if this one is here, so we can mark all of them as okay one island. So if we now traverse, if we traverse go here, so this will be actually like we will count again. So if we come on this one, so on every one we will initiate a like an algorithm to mark all the ones that are adjacent to it. But if you see carefully, if we run a loop, okay, we run a function on this one, so it will mark all the ones, okay, it will mark all the ones. So island will be one island variable will be incremented, it will come to 1. Now when we come to this one, actually the second one that we are having, so this one, so it will also start initiate the same function. So it will again mark this island as 1, so it will be like this one will be incremented and it will become 2. So this is not correct actually. So it will count a single island multiple times. So to deal with that, what we can do is, when we are on particular one, when we are traversing this matrix using 2 for loops, when we are on this element, okay, we will initiate some function actually, so which will mark all the elements. So we are on this element, so which will mark all the elements adjacent to it as one island. And instead of keeping them their value as 1, what we can do is we can mark them with another value, which we will use to check if it is already marked or not. So for simplicity's sake, I will simply mark the 1 as 2 if it is visited. So if it is visited or it is marked, you can see it, we will mark it as 2. So this is also visited, we will mark it as 2. So when this one is over, our variable is 1, its value is 1. So now when we come to next element, it is not actually 1, so that means it has been marked. So it is not 1, so we don't care, so we'll go to next. So you can see it is 0, so nothing will happen. So it is 0, so nothing will happen. When our loop will come here, you can see 1, so we will again initiate the function. So it will mark all the ones adjacent to it as an island. So but here no ones are there, so we will simply increment our this one to 2. So that means we have found 2 islands. You can see 2 islands. So now when our loop will come here, okay, so again 2 is there, nothing will happen, nothing will happen here, also nothing will happen. When we come here, this is 1, so we will same again initiate our function, which will mark all the adjacent ones or the lands to this particular one as 2 or another variable. That means they are visited. So you can see this is visited, so they will be marked as 2, 2 and 2 and 2. So when we mark them as 2, so our variable was incremented, it will become 3. So that means we have 3 islands. When we come to this 0, nothing will happen. When we come to this 0, nothing will happen. When we come here, there is 2, so that is not equal to 1, so that means they are already visited, so we don't need to do anything, we can simply return 3. So you can see this is our approach that we will use. So at every one when we get, we will initiate a DFS actually. So actually why we are using DFS? Because DFS is a recursive function, so we can use it to mark all the ones. So we need as I told you, we need to use a function which mark all the adjacent ones as visited, or like we can make it a another character, so that means it is visited. So that is why we will use a DFS function. So we will call a DFS function on all the 4 directions. For the lead code I am telling, so we will, if we are on this one, so we will call the DFS for all the adjacent nodes on the 4 sides. So first will be this, okay, right side, then it will be bottom, then it will be left side, and then it will be top side. So here when on this one, we call on the all 4 directions. So for this one there is no problem, but you can see on these directions they are out of bounds. So we will have to check for out of bounds. If this I gets less than 0 or j gets less than 0, so we will simply return. Or otherwise, if we are on this one, you can see, so these will be directions will be okay, but here you can see these are out of bounds. So for them we will simply return our function. So we will not do anything because they are out of bounds. So now this is the approach that we will using. So let's see the algorithm actually, so then you will get to know better. So this is the same example that we'll be using. So actually different, bit different. So let's see. So you can see, as I told you, we will have to traverse the matrix first of all. So if we don't traverse the matrix, we will not able to find all the islands. So we will have to traverse a matrix. Then you can see this grid is actually our matrix. So if our I and j, so our I and j is at this point initially, so we'll check if it is 1, so that means it is a land. So we will increment our islands variable. So islands variable, so let's assume this is I, so we will increment it to 1, so it will become 1. So now we will check for all the, we will call a DFS function. So actually DFS function will be our helper function, which will mark the adjacent ones or the islands to this island as visited. So for using DFS, we will pass the arguments as this matrix that we will have to pass, and then the I and the j coordinates, that means the cell that we are on, and then the bounds or the number of rows and columns. You can see n and m, and here we will check if this is in the bound or not. When we call for the top direction, when we call for this particular element's top direction, so it will check Okay, but first of all, it is inbound. You can see I and j are inbound, so it is 0 and 0, so they are equal or greater than or equal to 0. So that means we will mark it as 2. So that means it is a land, we will mark it as 2. Then we will call dfs recursively same function on the adjacent cells. So you can see this will be x plus 1. X is actually row, so it will call here x, and you can see y is same. So that means in same column we will call for this. So again, in this function it is inbounds. You can see it is inbounds, you know that, so it will be marked as 2. So that means visited. So you can see again this function will call for recursively for this function. It has returned the value, so it has actually returned 2. So again we will call for these functions. Okay, in this function we are on, so we will call the dfs for this adjacent cell. So it will also call the dfs for the adjacent values. So that means for its 4 directions, on the bottom side, on the right side. So again when we are in this function, when we are on this element, okay, we have a recursively call for this element, and this element will again recursively call for the same function on its all the 4 directions. So it will call recursively for here. Okay, then it will also call recursively for this point. So when at any point our bounds get or like our this I and j gets less than 0 or greater than n or m, so we will simply return that function. At this point we will check the bounds. If the bounds are not satisfied, we will simply return our function, so nothing will happen. And when we end this function, okay, when all the adjacent are marked, all the adjacent lands are marked, so that marked, so that means there is no okay one or no land, so we will simply return from that part. So it will return, okay, this value will return, and now we will be on all the elements are marked as 2 now. So let me actually change them. Not right here, you can see all are marked as 2. So when ing comes here, so we will check if it is 1. So if it is not 1, so that means nothing will happen. So it will come for this point, this point, this one, nothing will happen. And for this also, this is 2, so that means it is marked, nothing will happen. When we come to here, this point, so now it is 1. So again we will increment our island, so island will be incremented, it will become 2. So now we will again call the dfs for this point. When we call dfs for this point, you know that it will be marked as 2 before, so it will mark as 2. Then it will call for recursively for all the 4 directions. So you can see all the 4 directions are actually like not 1. So that means we will here check here also this also condition that if it is not equal to 1, we will return. If so we'll actually check for the 5 conditions. If I or j is less than equal to 0, or if I or j is greater than n or m, or otherwise if the cell is not 1, so we will return. If it is not so, that means it is 1. So if it is 1, so it will also recursively call, it will mark as 2 first of all, then it will recursively call for 4 directions. So that will what will happen. So now for this one, you know that there is no adjacent land, so it will be simply marked to 2 and nothing will happen, and the I is incremented. So now it will return. Now when we reach here, so it will again, it will check if it is bound. So it will be first of all marked as 2, and it will be bounds are checked, so it is in bound, so it will mark as 2. So now it will be recursively calling for all the 4 directions. When it is called for this direction, it will mark this as 2, and it will again recursively call for all the 4 directions. But you can know that either in these directions they are out of bounds, so it will return simply, function will return. And on these directions you can see when we call, so they are not equal to 1. So if they are not equal to 1, then also this function will return, so nothing will happen. When this loop ends, we will have the number of islands. So islands totally incremented 3 times, you know that, totally incremented 3 times. So that means our output will be 3. So we will simply return the islands. On the Geeks for Geeks, when we run this function on the Geeks for Geeks, we will have to add actually 4 more positions or the directions. So these were the 4 directions. You can see top, if we are on this element, these directions are actually this top, okay, left and bottom and right. And in Geeks for Geeks, we will have to write 4 more dfs calls. So that will be for this direction, okay, and this direction, and this and this. So you can see totally it will be 8 calls. Actually you can see this will be just different on the Geeks for Geeks. And what will be the time complexity for this solution? Actually, as you know, we are traversing this matrix, okay, we are traversing this whole matrix. So our time complexity will be row into column. As you know, we will be using 2 for loops to traverse the matrix, so it will be row into column. And our space will be actually nothing, it will be constant, because we are only updating our matrix, this matrix that we given, and we are updating the particular one as 2. So nothing will happen. But we will, if we consider the stack space, because we are using recursion, so for every function it will save into be for function call, it will be saved into the stack. So there will be some memory, but actually the space complexity will be 1. If we use a different visited array, so the space matrix, then space complexity will increase to row into column. So let's see the code, and I will explain you the code there. So let's see on the Geeks for Geeks first of all. So actually if you see, so this is the main function that we are given. So we are given a grid. So then we will check, we will first of all get the rows, size of the rows and columns. So actually you can see grid size dot size, so it will return the size of the rows, and then grid dot zero. So grid dot zero is actually this particular row, and it will return the size of this. For the rows it will return the size of this matrix, okay, this. So let's see. So if the rows are 0, so we can simply return 0. That means there are no rows, so that means our matrix is empty, so there will be no island, so we can return 0. So then we will check, make our counter variable, that is number of islands. So then we will traverse for all the cells, that will be I from 0 to rows and j from 0 to columns. Then we will check if the particular, so actually you need to consider it as a character. You can see they are characters, not integers, so you will have to write this as this. So you can see if grid is equal to 1, so we will increment our islands variable and we will call for DFS. So when we call for DFS, it will the control will come to this function. You can see we will have pass of a matrix, the current cells coordinates, and the number of rows and columns. So we will check for the outer bounds. If our x or the current variable is less than 0, so we will return. If it is greater than the number of rows, we can return. If the columns are less than 0 or greater than the number of columns, we can return. And if our matrix x and j, the particular cell that we are on, if we have called for this function, this 0, so if we will check if it is not equal to 1, so we can simply return, because if it is visited, if it is 2, so then also we can return. So then if it is not so, that means we are in bounds and this island is 1. So that means if for this island we have to call this function on this particular part, so you can see then it will again recursively call for all the 4 directions, and it will mark all the islands on it four directions as visited. So you can see this will be x plus 1, that means on same column and on the next row, and this is x and y plus 1, that means on the same row but on the next column, and this is actually x minus 1, that is on the previous row and same column. Okay, so this you can see 4 directions. This is actually simple. So then we don't have to return anything, it is actually void, because whenever we get out of bounds, so it will simply return. So when we end this function, okay, when this function is ended, so it will again call for the all the cells values which are 1, so it will mark them and island will be incremented. Then we will simply return our number of islands. So let's see, submit the solution. So let's see. So you can see this solution got submitted, and it was faster than 96.48% of solutions, and it also took less memory than 65.56% of solutions. So let's see on the Geeks4Geeks, the same code I have used on the Geeks4Geeks also. So you can see we have a DFS function and we have a main function. So in this also we have got the main function, and we have also got the number of rows and columns in there also there only, so we don't have to find it. So we will initialize our islands variable, then we will traverse over this matrix and we will check if it is equal to 1. In this Geeks4Geeks we have given the integers, so this is not the characters, so we are given integers. So we will check if it is equal to 1, so we will simply call the DFS and we will increment our islands variable. And here we will check for the outer bounds if it is not in the bounds, and if the value is not equal to 1, and then we will mark it to the another value, that is 2, that means visited, and then we will call for the 4 directions. You can see there actually 8 directions. So first will be top, bottom, then left, right, and then the you can see this top left and top right and bottom right, left and bottom right. So that means 4 directions. So this function will be called for the 4 directions, and it will mark all the adjacent lands to visited if it is 1. So then we will again come to this point, and then again island will be incremented if there are more islands. So let's submit the solution. So I hope you got this solution and got to know how to solve this. I will also provide the code for the both code in the description, so you can check the code for your reference from there. So thank you for watching, guys. So you can see it got submitted. Thank you for watching, guys. Do like this video and subscribe to the channel for more such videos. Thank you for watching.